Compared to old technology aircraft, the flight deck on the A330 is designed to be a comfortable, uncluttered environment in which to work. By utilizing modern electronic display units, the presentation of information to the pilots has been improved.
The Electronic Instrument System, EIS, consists of 6 identical liquid crystal display units, LCD. The EIS is divided into 2 subsystems. The Electronic Flight Instrument System, EFIS, for which each pilot has 2 displays. The Electronic Centralized Aircraft Monitoring System, ECAM, which uses the 2 displays in the center to provide information on the aircraft systems. Let's look at the EFIS system first.
Flight parameters are displayed on primary flight displays, PFDs, while navigation data is displayed on navigation displays, NDs. Outboard of the PFD are control knobs to adjust the brightness of the associated PFD and ND, or to turn the display off.
A switch is provided to allow the information on the PFD and ND displays to be transferred. At the top of this panel, a switch allows the pilot to manually select the data source for his PFD, ND. The 2 displays in the center are dedicated to the Electronic Centralized Aircraft Monitoring System, ECAM. At this stage we will simply introduce the ECAM displays and the related controls. A is called the Engine Warning Display, EWD. The lower ECAM display is called the System Display, SD. Various aircraft system parameters can be viewed on these screens. As an example, you can see a sequence of all SD pages, one after the other. Another philosophy used on the flight deck is the lights out configuration. When the aircraft is in its normal flight state, there will be no white lights illuminated in any of the switches on the overhead panel. As an example, just before takeoff, if you look up at the overhead panel, there should be no white lights on any of the switches. Let's look at some switches. For the majority of the switches on the overhead panel, the push-button switch logic is normal configuration, no lights showing. The lights out philosophy, abnormal condition, amber fault light. This helps to identify the switch related to an abnormal condition. White light, if normally the system should be operating and is deactivated, a white off light comes on. If normally the system should not be operating and is activated, a white on light comes on.
There are some switches on the overhead panel which are used on a temporary basis, or may have an indication of their state. The logic is temporary selection for operational reasons, blue on light, for example anti-ice, and applicable system status, green light, for example APU available. You will see this philosophy demonstrated throughout the course.
The ECAM control panel is on the center pedestal, below the ECAM displays. On the left-hand side, 2 controls turn on off and adjust the brightness of the 2 ECAM screens.
Just to the left of the ECAM lower screen is a switching panel for use in abnormal situations to restore data to the ECAM displays. You will use this panel in the EIS reconfiguration module. In front of each pilot there are two attention getters, a red master warning and an amber master caution. As a further means of getting the pilot's attention, there is a loudspeaker on each side of the cockpit for oral alerts and voice messages. Note, the loudspeakers can also be used to listen to radio communications and the intercom. Now, let's go back to the EIS system. For the EIS displays, data from the Air Data and Inertial Reference System, ADIRS, plus navigation data from the Flight Management and Guidance System, FMGS, is fed directly to three Display Management Computers, DMC. The three identical display management computers process the data and generate the images to be displayed. Under normal circumstances, DMC-1 supplies EIS information to the captain's PFD and ND. DMC-2 supplies the first officer's PFD and ND. And DMC-3 is available as a backup. You will see the use of DMC-3 in the Abnormal Operation module. Now, let's look at the other EIS subsystem, ECAM, and how the ECAM displays gets its data. Sensors are fitted throughout the aircraft to monitor the various systems, including system controls operated in the flight deck.
Data for certain parameters, for example, fuel quantity and primary engine indications, is routed directly from the system's sensors to the three DMCs. Note, there are separate channels within each DMC for ECAM and EIS. Each DMC can simultaneously supply one PFD, one FD, and both ECAM display units.
For the majority of the systems, the sensors supply data to two System Data Acquisition Concentrators, SDAC. The SDACs acquire system data, process it, and send system page data to the three display management computers. Normally, DMC-3 supplies the ECAM system, and DMC-1 and 2 are available as backup.
Two identical flight warning computers, FWC, receive data from the aircraft system sensors to generate red warnings and the SDACs to generate most of amber cautions.
The flight warning computers then supply the DMCs for the display of alert messages, the attention getters, the loudspeakers for oral alerts and synthetic voice messages.
All the components shown can be collectively called the ECAM system. We will study the use of the ECAM system in a separate module.
In addition to EIS and ECAM, time measurement devices are provided. The master time reference for all aircraft systems is provided by a clock located on the left lower side of the main panel.
The time is also displayed at the bottom of the system display. In this module, we have introduced you to the Electronic Instrument System, with its two subsections, EIS and ECAM, and the clock. In the next modules, we will concentrate mainly on the ECAM system, and then later in the course return to look at the EIS displays in greater detail.